What is related rate? Related rate is a part of the application of differentiation in the fundamental theorem of calculus. Related rates problem usually involve two or more variables that change at the same time, possibly at different rates. If we know how the variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing. This usually involves writing an equation relating the two variables and taking the derivative of the equation with respect to time.
For introduction, let's take a look for some of the shapes that are focused in related rates. Shape for related rates. Number 1, we have cube. Number 2, we have cylinder. Number 3, we have cone. Or number 4, we have sphere. And the last one that we are focusing on related rates is hemisphere. Time to look in deep on how to solve related rates question. Let's go. To understand more about this topic, let's look at this one example. Let's go. So the problem statement in here is that an ice cube in shape of cylinder is melting as shown given. Details on cylinder: radius is 6 cm, ratio is 4, and the height is r plus 4. So in order for us to solve the problem, we are going to find the surface area of the ice cube in terms of r, find the volume of ice cube in terms of r, find the rate change of the surface area. So the first one, we are going to find the surface area. We are going to use the formula of surface area, which is A 2 pi r power 2 plus 2 pi h, and then we are going to put the h term, which is r plus 4, and then we are going to expand the answer to make it more easier, and the final answer that we will get is 4 pi r power 2 plus 8 pi r. The second one is we are going to find the volume of the ice cube. We are going to use the formula for volume, which is V pi r power 2 of h, and we are going to put the h terms in the formula, which is pi r power 2 r plus 4, and then we are going to expand it, and we are going to get pi r power 3 plus 4 pi r power 2.
For the question number 3, we have to find the rate of change of the surface area of the ice cube when the radius is 6 cm. From the question, we know dV dt is equal to negative 4 cm per second. We have to find the dA dt when r is equal to 6 cm. We have to remember that to find dA dt, we need to make dA dV times dV dt. Because when we cancel dV, we will get dA dt. But there is no way that we can get dA dV, so dA dV need to be separated. This is what I mean by separating dA dV. Area is equal to 4 pi r squared plus 8 pi r. To find dA dr, we have to differentiate the area. So dA dr equal to 8 pi r plus 8 pi. Volume is equal to pi r cubed plus 4 pi r squared. To find dV dr, we have to differentiate the volume, so dr dV is equal to 1 over 3 pi r squared plus 8 pi r. After we put together all equations for dA dt, we will get negative 32 pi r minus 32 pi over 3 pi r squared plus 8 pi r. When r is equal to 6, we have to replace r in the dAdt equation with 6, and we will get negative 56 over 39. So for the answer of the question number 3 is the rate of the change is negative 56 over 39 centimeters square per second.
As we can conclude, the objective used in this problem solutions are accepted because we succeed to find the value of rates. But for the other different kind of shapes that are not like the example shown in this video, you do not have to worry, because the rate of change can be determined by using differentiation. In that case, we can calculate the differences between the change that occur with accuracy. It means that even if it were different shapes, if it is a related rate problem, you can still solve it by using differentiation.